Good morning, class. I hope you had a nice Monday and you were able to look at the video and do the worksheet that I asked you to work on in terms of review. Today, I figured I'd do something a little different. I give you a chance so you can take a look and actually see me as we are talking today, give you more of a personal touch. I know you haven't seen me. I haven't seen you guys in forever. It seems like forever. But today we're going to move on in our lesson talking about Table G. And once again, on Table G, we're talking about the solubility of different salts. And we see that sometimes the solvent is not in 100 grams of water. So we have to understand when it is in 100 grams of water and when it's not. The first episode that we saw yesterday was in 100 grams of water. Today, these are not going to be in 100, which means it's going to revolve around one extra step. When the solvent is not in 100 grams of water, you must be careful. There's the extra step that's needed before you make your comparison and you make your identification. Now, luckily for us, the amounts of water are always going to be in increments of 100 as we go above. So if I'm above 100 grams of water as my solvent, what we're going to need to do, as we talked about in class, is you're going to need to multiply what you find on Table G before you make any comparison. And again, it's always going to be in multiples of 100 for us. So if we have 200 grams of water, I'm going to multiply by 2, then look up my answer. 300 grams, multiply by 3. 400 grams, multiply by 4. So you see that we multiply by the whole number of the hundreds. So 200 is 2, 300 is 3, 400 is 4. Now, once we multiply, we then compare to what's on Table G, as we always do, and then see, is it on the curve? Saturated. It's above the curve, supersaturated, or if it's below the curve, unsaturated. So that's when we have solvent above 100 grams of water. If for some reason we have below 100 grams, and again, this is definitely a possible outcome, here we're going to divide what you find in Table G before you compare. And the great thing here is the only one we have to worry about is when it's 50 grams of water. When it's 50 grams of water, we're going to divide by 2, then we're going to make a comparison. And then as always, if it's on the curve, saturated, above, super, and if it's below, it's going to be unsaturated. Let's take a look at some of these examples. We're going to use Table G, as we always do, but we're going to classify the following, noting the different amounts of solvent for each piece. So if we do that, we're going to need Table G, and we're going to be careful of how we're looking things up. Take a look at this first one here. This first one, it says, classify the following: 70 grams of NH4Cl, ammonium chloride, at 50 degrees Celsius in 200 grams of water. Now, in the first episode yesterday, we saw always 100, 100, 100. We didn't do anything different. It was just look it up, find the answer. For these, we must be careful because now we see that it's different amounts of solvent. So this says 200 grams of water, right, at 50 degrees Celsius, ammonium chloride. So if we take a look at Table G, 50 degrees Celsius for ammonium chloride, and I'm going to put my mark exactly where that's going to be. It's right about there. And remember, this is in 100 grams of water. So what I found was ammonium chloride, there's 52 grams in 100 grams of water. What we need to do is go back to our problem. It says 200 grams of water. So that's going to be 52 multiplied by 2. So 52 times 2 is 104. So what I actually found out is that there is going to be 104 grams. Again, 52 times 2. That would make it saturated. But what do I have? I have 70 grams of this substance. 70 is less than 104. So I would know, and I'm going to change my color for my answer, that this is going to be unsaturated. Again, the reason it's 52 times 2 gives me 104. That would be saturated, but 70 is below. So 70 is going to be below and it's unsaturated. Take a look at number 2. It says 210 grams of NaNO3 at 10 degrees Celsius in 300 grams of water. So for this one, I'm going to change my color once again, and I'm going to make note that it's 300 grams of water. Tells me it's not a normal problem. So I have to look at NaNO3 at 10 degrees Celsius. NaNO3 at 10 degrees Celsius. I'm going to come up and I'm going to place my mark. Boom. Exactly 80. But that's 80 in 100 grams. My question is in 300. So for this one, it's going to be 80. Oops. Hold on for a second. It's going to be 80 times 3. Because again, it's 300 grams of water. So that's going to give me an answer of 240 grams of solute. So now I'm going to compare. 210 is below 240. So this one is also unsaturated. And again, I apologize with the writing. I'm still getting used to all of this stuff. So notice that it's not something that is that hard to do as long as you know where things are taking place. All right. So my third example here, I have 10 grams of KCl at 25 degrees Celsius in 50 grams of water. So let me just get out of this here. Good. So I'm going to take my new color and I'm going to have 50 grams of water here. So now 50 grams, I'm dividing by 2 whatever I find on table G. So that's KCl at 25 degrees Celsius. So back to my chart. KCl at 25 degrees Celsius is right there. KCl. So I'm going to estimate that at 34. Okay. 34 would be in 100 grams of water. But I have 50. So it's going to be here 34 this time. And we're dividing by 2. So that makes this 17. Notice 17 would be saturated. 10 is below. So that's going to be unsaturated. Okay. Everyone see that? Again, you just got to be careful about what you're doing and what you're looking at on table G. Again, I always encourage to use a highlighter on some of these questions or a colored pencil so you can know exactly which ones you're going to look at before you make a comparison. All right. So let's just take a look again and let's take a look and we're going to, let me get out of here real quick. Come down to my next set of problems for practice. Okay. So now we have 20 grams of NaCl at 90 degrees Celsius in 50 grams of water. So once again, 50 grams of water, NaCl at 90. So at 90 degrees Celsius, NaCl normally right there, boom, has a solute of 40. 40 is in 100 grams. 100 divided by 2 for 50. So that's going to make this here 50 grams of water. So I'm going to take 40 and I'm going to divide 40 by 2. That makes this 20. So 20 would be saturated. And notice 20 is what I gave you. So 20 equals 20. So for this problem, it's going to be saturated. Not too bad, right? Let's go to number 5. Number 5, let's use yellow this time. We haven't used yellow in a while, okay, at all. So here I have 200 grams of water, right? So 200 grams of water. This time I'm looking at SO2 at 10 degrees Celsius. So 10 degrees Celsius, I'm looking at SO2. Boom, right there. I'm going to estimate that to be about 17. So 17 grams is what's in 100. So I said 200. So that's going to be 17 times 2. So that's 34 grams would make me saturated. I only have 15. Notice 15 is below 34. So this problem would be unsaturated. Okay? So in our last problem, let's see if we can use an orange red. Says we have 300 grams of water of HCl at 50 degrees Celsius. So HCl at 50 degrees Celsius. 50 degrees Celsius, HCl is right there. Boom. I'm going to estimate that to be about 58. So 58, that's normally in 100. This says 300. So that's going to be 58 then times 3. So I would take my calculator out because that's not an even number to work with. No harm in double checking. 58 times 3 is 174 grams. So 174 would be saturated. I only have 40. So 40 is below 174. So that would be unsaturated. Again, these things, like everything else in chemistry, takes time, takes some practice. So hopefully you can go back, take a look at this video one more time, practice these things on your own, and make sure your answers match my answers. And then just like yesterday, I'm going to post a worksheet with like 6 or 7 problems that I want you to work on and send back to me. So that way I know that you actually watched the video and took care of things. All right, everybody. Hopefully you liked this instructional video with Table G and different amounts of solvent. I hope you liked the addition of me adding my face to make it a little bit more personal for you. So DeMarco is going to end today's. Chemistry always involves trying, so please make sure you're trying things out and everything works.